Okay, so this is the setup and solving for the problem that says investing at $2,000 at 9.5%. Again, that's 0.095 as a rate because it's a decimal, continuously compounded. So that's your P times E to the RT formula. Again, make sure that you know that. Here's the arithmetic involved. Comes down to solving it again, remembering that when we use a natural log on both sides, that allows us to pull the exponent to the front. And because we use natural log with the base of E, it became 1 and solved it out from there. But here's the interesting fact about this, and this is going to blow your mind for a second, but then it's going to make a lot of sense to you. If this problem had been changed, and I said we had 2 pennies, and we wanted to invest those 2 pennies until the 2 pennies became 5 pennies, it would take, what did we get as the answer here? Yeah, 9.6 years. It would take 9.6 years for a 2 penny investment to become 5 pennies. And the whole reason is you would have 0.02 times E here, and you're wanting to become 5 cents, so you'd have 0.05. Well, your first step would be to take 0.05 and divide it by 0.02. When you divide 0.05 by 0.02, that's the same thing as dividing 5,000 by 2,000. So it still becomes 5 halves there. So it's a little wild, I think. But you know, same thing. If you take $2 million and invest it to become $5 million, still 9.6 years under those circumstances. So let's keep moving on with logarithms. Now, in just a regular logarithmic equation, there are 2 strategies. One of the strategies is to get a logarithm set equal to a value. Like, let's say we work an equation and we end up with the log base 3 of x equals to 2. Well, that means that 3 squared would equal to x, so x would equal to 9. In other words, you take a single logarithm equal to a number and you write it in an exponential form to solve it out. That's one method. The other method is to get a single logarithm, and I'm using log base 3, I don't know why, just am. Yeah. Yeah, so if the log base 3 of x is equal to log base 3 of 8, then would that not make sense that x would have to equal to 8? In other words, you take your logarithms out to solve it out to get the answer. So those are our 2 strategies. Now, I know it's hard to believe, but not all the problems are going to be that easy. That's a shocker. So, let's look at one that's a little bit more involved. Let's say that we have the natural log of x minus 3 minus the natural log of x plus 3. And we're going to set that equal to the natural log of 2 over x. Okay? Well, we get to here, and we can't just drop the natural logs. What's wrong? I know. That'd be nice, wouldn't it? X minus 3 minus, well, your x is, that'd be a weird problem. Because we need a single logarithm equal to a single logarithm. Now, do you remember when we had subtraction of logarithms? Remember, we're subtracting exponents. What kind of problems do we subtract exponents in? Division with like bases, right? So this becomes the natural log, and again, the base is e here, of x minus 3 over x plus 3 equals to the natural log of 2 over x. Well, what do we have here? A single logarithm equal to a single logarithm, right? So x minus 3 over x plus 3 is going to equal to 2 over x.
Okay, so you put, x minus 3. So, so you're saying it's because logarithm are exponents, the reason you put them as a fraction, because it's essentially, that's when you subtract exponents?
Yes.
That fraction? Okay.
Yes.
Okay.
You subtract exponents in division problems of like basis. All right, so now, at this point right here, I know that x cannot equal negative 3 and x cannot equal 0. So, with that in mind, I can cross multiply here. So, I get x squared minus 3x equals 2x plus 6. So, subtracting, I get x squared minus 5x minus 6 equals 0. It's a quadratic. Are we good here?
1 6 equals
Jameson, for you, I'll give you 2 seconds. I'll do that for just anyone. I wouldn't do it for Noel.
Alright, I got it.
All right, so this becomes x minus 6 times x plus 1, right?
Yeah.
So we get x equals 6 and x equals negative 1. Yes? You sure do get picky. Sorry about that. All right. Now, there's one thing to keep in mind. We know that we didn't get either of these answers, so we're fine as far as that's concerned. But we also have to make sure that when we're taking the log of a value, we're not taking the log of a negative number. Well, if I take negative 1 and I plug it in here, what's 2 divided by negative 1? It's a negative value, right? So I can't do that. I couldn't put it over here either. So negative 1 is not going to be part of my solution. All right, let's try 6. What's 6 minus 3?
3.
Positive, right?
Positive.
Positive? Positive. Okay, so we're good there, right?
Right.
So my only solution here is 6. Don't miss that on a problem. Don't do all of that work, get the right answer, and then miss the problem because you didn't go back in and check it. And it's not because this number's negative. It's because when you take this number and plug it in here, you get a negative number. Now, the majority of the times in the problems we have, if you get a negative answer here, the majority of the time it's going to lead to a negative value up here. But you still need to check it. Because if it had been 3 minus x instead of x minus 3, well, 3 minus negative 1 would be fine.
So it has to be positive?
The end result here has to be positive, yes.
You basically saying when you plug it back into it, if you do like, say for instance, when we plug 6 in, we get all positive values. But like if you put negative 1 in for x, like 2 over negative 1 is going to be a negative. So if any of them end up with a negative, you don't, that number won't work.
Let's just say that we had solved out an equation, and the equation we'd solved out had started out as being square root of x minus 3. And I had several people miss this on the last test. And you solve it out, and let's just say that when we solve it out, we get x equals 6 and x equals 1. That's our solution here. Well, 6 is fine. I can plug in 6. 6 minus 3 is 3. We're fine there. But yeah, if we had solved and got x equals 1, 1 minus 3 is negative 2, so it wouldn't work. But I had a lot of people who didn't go back. They got the correct answers, but they didn't go back in the end to check it to make sure that everything worked out. So it's the same thing here. You've got to make sure that the answers fit what the domain should be.
Also, I think about it as x minus 3 would have been the answer to the exponent, and the exponent can't have a negative answer. Like how?
Well, you can have a negative exponent, though.
No, not a negative exponent, the answer to the exponent.
Oh, yeah, because if you have a base raised to any number, if the base is positive, your answer is going to be positive. That is correct. All right. Okay.
Would we multiply x and x?
Yes. So we get the log base 8 of x squared plus x equals, this should be 2, sorry.
Oh.
I need to change that here. All right. So now we have a single logarithm equal to a number. So we could write that out in exponential form. So that means that 8 raised to the first power is equal to what? Well, x squared plus 2x. Are we okay here? All right. So 0 equals x squared plus 2x minus 8. So this factors into x plus 4 and x minus 2, right? So x equals -4 and x equals 2. Okay, let's check it. All right, -4, if I plug it in there, doesn't work, does it?
So the two
Two.
work.
Yeah, 2 works, right? So we're good there.
Okay, so why did you? Okay, in the last problem, we didn't bring the LN down. Like when we got to, we had x minus 3 over x plus 3 was 2 over 8. Why is it that we brought the log of 8 down this time when we had?
We did bring it down.
We did.
Yeah, we had the natural log. When we did the division, we had the natural log of x minus 3 over the natural log of x plus 3 equal to the natural log of 2 over x.
Right.
And see, at that point, we were in a situation where we had the natural log equal to the natural log.
So you just can't.
So the natural logs just go away.
Oh.
Here, if this had been the log base 8 of 1, then I could do that here.
Okay.
But that's not what we have here.
And so you did 8 to the first power because why did you do it?
I had it in exponential form.
Okay.
B raised to the m power equals n.
Because that's one of the.
Yeah, that's one of the properties,
Okay.
yes.
Okay.
So remember, I said we had 2 strategies when it comes to
Solid.
solving logarithmic equations. One strategy is to get a single logarithm equal to a single logarithm, and then the other one is to get a logarithm equal to a number and then make it exponential. Did you have a question?
When you check, you plugged it into what's in parentheses,
I plugged it in everywhere I had a log.
okay.
Yeah, but everywhere I plug in -4, I'm gonna get a negative. But 2 gives me a positive in both cases. You good with that? All right. Can I erase this? Okay. All right. Now, would y'all agree that this exponent is half of this exponent? I'm sorry, this exponent is half of this exponent. I hope you don't agree with the other thing. This exponent is half of this exponent.
Great.
Okay. So, because of that, I've got something that is in quadratic form. Now, I'm going to rewrite this first equation, or this first exponent. this first exponent, I'm gonna make it 3 to the x power squared. And that's okay to do, because when I have an exponent raised to an exponent, it's the same thing as multiplying those two values together. So 3 to the 2x is the same thing as 3 to the x to the second power.
Yeah, you should already.
Yeah, just wrote it a little bit different. Now, I'm going to do something a little bit different here. I'm going to do something called u substitution. I'm going to let u equal to 3 to the x power. If u is equal to 3 to the x power, then I can rewrite this equation as being u squared plus 3u minus 30, no, not 3u, because I made it 3u, minus 30 equals 0.
That's just a quadratic too.
So now I've got a quadratic, right?
Correct.
So now I factor it. How does u squared plus u minus 30 factor out?
X minus 5 and yeah.
Very good. Everybody okay with this? So, u equals negative 6 and u equals 5. Wait, don't do that yet. Don't do that yet. Because I'm not solving for u, am I? I'm solving for x. So at this point right here, I'm going to rewrite the problem as being 3 raised to the x equals negative 6 and 3 raised to the x equals positive 5. Is there a question about that? All right, well now, let me, I'm gonna take the natural log of both sides so I can pull the x to the front. So I've got x times the natural log of 3 equals the natural log of negative 6. And here I have x times the natural log of 3 equals to the natural log of 5. Are we okay here? What's the natural log of negative 6? Can't be done, because we're taking the log of a negative. So that one's not going to work out. But here everything's positive, right? 3 and 5. So I'm going to say that x is equal to, remember this is a product of two things. This is like saying 3x equals 5, and how would you solve 3x equals 5? You would divide both sides out by 3. Well, the natural log of 3 is a constant also. It's an irrational constant, but it's a constant. So I do that arithmetic, and y'all do that. Round your answer to 2 decimal places. Yes. Yes.
1.46.
1.46 is the correct answer. Now, I'm going to have to say approximately equal to, because that is not the answer, but x is approximately equal to 1.46. So if I went in here and I plugged in 1.46 for x, I would get an answer very, very close to 0.
Right.
Everybody okay with that? All right, got one more type of problem to do. Yes, I would love to. That's the reason I want y'all to practice on it today. So that when test time came, you'd be good with the calculator. So you've got the natural log of 5. Okay, yeah, you needed to close. So I'm going to insert second insert, and I'm going to shut that parentheses off. Does that make sense? All right, good. Alright, I wanna solve that one out. Got a base of 5 on the left side, and then the other side I have the cube root of 5.
I feel like we're gonna try to get the same basis.
We'll try to get the same basis. It's all about that base. Right, Kara? Alright, so anyway, how can we rewrite the cube root of 5 as an exponent?
5 to the 1/3.
Very good. So what do we have here? We have an equation, and in that equation, we have equal bases. So again, like when I'm in my car, I'm going to drop that base. Golly, I'm good. Y'all haven't gotten tired of that one yet, have you?
I know, man.
So x plus 2 over 3 is going to equal to 1 over 3.
Right.
Well,
-1.
if your fractions are alike and your denominator's the same, then you could just say x plus 2 equals 1, so x equals negative
Right.
1. And it's okay to get a negative here, because if I take that negative and plug it in, it's fine. I can get positive or negative exponents. There's nothing wrong with either of those. So that is a legitimate answer to get.
Very simple.
And it works out fine. So this was a case where we had a variable in the exponent, but we were able to solve it without logarithms. I mean, we could have done a logarithm and gotten the correct answer. We could have taken the log of both sides. We would have eventually gotten the right answer, but the easiest thing to do is recognize, hey, if your bases are alike, then your exponents must be equal to each other if it's an equation.
Yeah. Ain't no reason to make it hard.
You're right about that. All righty.